Did you know that nearly half of our planet's population depends on rice as their main food source? That's over 3.5 billion people relying on a grain with a fascinating, high-tech journey before reaching their plates. In the next few minutes, you'll discover how rice transforms from plants in flooded fields to the perfectly sorted grains in your kitchen. From combine harvesters processing thousands of pounds per hour to advanced color sorting machines examining every individual grain, the technology behind your simple bowl of rice reveals an astonishing marriage of nature and innovation. The remarkable systems that bring this humble grain to billions worldwide will truly amaze you. If you enjoyed this, make sure to like the video and subscribe for more. Ever wonder how those tiny grains of rice make their way from muddy fields to your dinner plate? The journey starts with farmers who are masters of timing and precision. Before any planting happens, they carefully prepare the fields in July and August by leveling the land and adding fertilizer to give the rice plants everything they need to grow strong and healthy. As summer transitions into fall, October marks planting time. Farmers use automatic planters that spread rice seeds evenly across the fields, ensuring uniform distribution, crucial for a successful harvest. The defining feature of rice farming is water management. Rice paddies are essentially flooded fields where plants thrive in wet conditions, creating an environment that naturally suppresses weed growth, since most weeds can't survive in standing water like rice can. Throughout the growing season, farmers maintain precise water levels in the fields, orchestrating a delicate balance that nourishes the crop. Before harvest, timing becomes critical. Fields must be drained at exactly the right moment. Too early or too late, and rice quality suffers, potentially compromising an entire season's work. Once fields are properly drained and the rice matures, harvest begins with the arrival of combine harvesters, mechanical giants that sweep through the paddies with rhythmic precision. Like dancers moving across a golden stage, these machines cut down rice plants while simultaneously separating valuable grains from stalks through threshing, performing dual roles in a single choreographed pass. The efficiency of modern harvesting unfolds in a carefully coordinated performance. Inside the combine, separated rice collects in a hopper as the machine continues its steady progress through the field. When full, rather than pausing its work, the combine transfers rice to a chaser bin, towed by a tractor running alongside. A synchronized partnership that maximizes harvest speed and efficiency. After harvest, trucks transport rice to storage facilities where rigorous quality control begins. Each delivery is weighed upon arrival, with samples taken for laboratory testing. Technicians measure moisture content precisely while using specialized thermal lamps to detect any hidden insects. The standards are incredibly strict. Finding just one moth or beetle in a 5,500-pound truckload results in rejection of the entire batch. The final preparation before processing involves adjusting moisture levels. Freshly harvested rice arrives with approximately 22% moisture content, which must be reduced to around 13%. Storage facilities use powerful systems that circulate hot air through the rice, gently drying each grain to the optimal level. This process hardens the grains just enough to withstand milling without breaking, striking the perfect balance between too dry and too moist. With moisture at the ideal level, the rice is ready for the factory processing line. With that perfect 13% moisture level achieved, our rice enters perhaps the most critical phase of its journey. The raw grains arriving at processing plants look nothing like what you'll find in stores. They're completely encased in protective hulls, mixed with field debris, and need extensive cleaning before they're recognizable as the rice you know. The transformation begins as moisture-balanced grains pour into the factory, where screening machines go to work. These engineering marvels shake and vibrate in precise patterns. They're specifically sized holes, allowing rice grains to pass through, while capturing larger materials like straw pieces and plant stems. Engineers have calculated the exact vibration frequency that maximizes separation while protecting the delicate grains inside their hulls. Screens capture many contaminants, but the factory's powerful pneumatic systems handle what remains. Like industrial-strength vacuum cleaners, these systems create carefully calibrated air currents that blast upward as rice cascades through the machines. The heavier rice grains fall downward, while lighter debris like empty husks and chaff gets carried away. A simple physics principle applied on an enormous scale. For stubborn contaminants like stones and pebbles that match rice in size but exceed it in weight, factories employ gravity tables, vibrating platforms set at precise angles. As rice flows across these platforms, vibration causes heavier objects to migrate uphill while rice moves downhill. The stones literally separate themselves out, protecting both machinery and final product. Then comes the truly transformative step. The cleaned rice enters hulling machines where precisely calibrated rubber rollers rotate at slightly different speeds. This creates a delicate dance of pressure, just enough shearing force to crack open the husk without damaging the grain inside. The machines maintain this perfect balance while processing tons of grains hourly. What emerges is brown rice, each grain wearing its nutritious bran layer that provides fiber, vitamins, and minerals. This transformation echoes ancient traditions of rice preparation that cultures worldwide have practiced for millennia, now accelerated through modern engineering. The process continues as sifting machines examine every grain, separating fully hulled rice from those with partial husks. Any incomplete grains get automatically redirected through the hulling process again. This recycling system ensures maximum yield with minimal waste, critical in an industry with tight margins. Throughout this factory metamorphosis, rice moves primarily by gravity, flowing downward through carefully designed chutes and conveyors. This approach remains both energy efficient and gentle on the grains. The entire system operates continuously, transforming field harvested material into clean brown rice around the clock. A remarkable journey from raw agricultural product to the recognizable food that will eventually reach your table. The rice's transformation is far from complete. Riding those gravity-powered chutes, our brown rice now faces perhaps its most radical makeover. Those uniform white grains in your kitchen didn't just happen naturally. They're the result of precision engineering that would impress even the most demanding perfectionists. Now comes the crucial sculpting phase. Brown rice enters milling machines where abrasive surfaces work like meticulous artists, carefully chiseling away the outer bran layer to reveal the pearly endosperm within. This transformation fundamentally changes the grain's character. White rice cooks faster, lasts longer on shelves, and delivers that mild flavor most consumers prefer. The process removes about 10% of the grain's volume, primarily the fiber-rich bran and germ portions, containing most of the nutrients. These milling machines operate with remarkable precision. They apply exactly enough friction to remove the bran without damaging the delicate endosperm. Factory technicians continuously monitor these settings, maintaining perfect balance between throughput and quality. After milling, we have white rice, but it's hardly uniform yet. Some grains are perfect, others broken, and many show discoloration. This initiates a revolutionary quality check that might surprise even technology enthusiasts. First, grading machines separate rice based on physical characteristics. These sophisticated sifters use screens with different size perforations to sort by length and width. The whole grains continue forward while broken pieces get diverted. These fragments aren't wasted. They're collected and sold as brewing rice for Seikan beer or ground into flour for other products. Then comes the truly impressive technology, optical sorting. These machines serve as superhero-level quality inspectors, with high-resolution cameras photographing every grain at speeds of up to 10,000 images per second. Software analyzes these photos in real time, identifying discoloration, spots, or any visual defects. When imperfections are detected, precisely timed millisecond puffs of compressed air blast rejected grains from the stream with surgical accuracy. These rejects are recycled for reprocessing or diverted to animal feed. The pristine white rice then moves to packaging. Multi-head weighers measure precise amounts for each package, calculating combinations from different hoppers to achieve target weights accurate within 0.1 grams. This carefully weighed rice drops into packaging machines that form bags from plastic film, fill them with the exact amount, and heat seal them for freshness. The journey culminates with final quality checks. Random packages undergo inspection for proper sealing, accurate weight, and correct labeling. Some facilities even employ metal detectors and X-ray machines before the perfectly packaged rice is palletized, wrapped, and loaded onto trucks. The final step in delivering those pristine white grains to your kitchen. Let me tell you something remarkable about those tiny grains you're cooking for dinner tonight. Rice feeds nearly half of our planet's population, making it the second most produced cereal worldwide. That's billions of people relying on this humble grain every single day. And it's been this way for thousands of years, especially across Asia where rice cultivation began. Next time you serve rice, remember its incredible journey, from ancient paddies to modern processing facilities before reaching your kitchen. Can you feel the pulse of history and innovation in every bite? Something so fundamental to human survival depends on such a precise, complex production system.